Okay, oops, starting this video over again the next day from this point. There was this number 52, which was the next problem, and it says, find the value of c guaranteed by the mean value theorem for integrals for the function over the indicated interval. Okay, so there's a lot going on in this problem. We have this function. The function is f of x equals 9 over x cubed. And we're given a particular interval, 1, 3. And this problem is addressing the mean value theorem for integrals, which is of big importance in understanding, in my opinion, the mean value theorem, or in understanding the fundamental theorem of calculus. And we talked about this in the video. What is the mean value theorem for integrals? Well, it involves the average value of a function. So we need to compute the average value of this function first on this interval. So let's do that by making a picture. So what does this function look like on this interval? Well, trying to do this roughly to scale. Here's 1, here's 3. When you plug in 1 here, you get 9. So maybe that's about right. And when you plug in 3, you get, is this the problem? On the interval 1, 3, yeah. That's interesting. Okay, so if you plug in 3, you get 1/3. Is that true? It just is true, yeah. 9 over 27. Okay, so if this is 1 or something, then when I plug in 3, I get 1/3. When I plug in 1, I do get 9. And when I plug in 2, say, I get 9/8, which is a little bit more than 1. So we have some function that looks like this. Okay, and, well, we already sort of knew 9 over x cubed kind of just looks like 1 over x cubed, just stretched out by a factor of 9. And 1 over x cubed is going to look, roughly speaking, like 1 over x. So here we go. Okay, what's going on is that we have some certain area underneath this curve, and this certain, certain area can be calculated. We're going to do that in a second. And then the average value of this function on this interval, just trying to fix my picture. The average value of this function on this interval is sort of answering the question, how big is this function on average? And so what we really want to do is somehow add up the infinite number of y values that this function takes on the interval 1, 3, and then sort of divide by the number of x values. Of course, both of those are infinite, so it doesn't really make any sense. But this is what we determined last class, or in the video, is that the average value of f on some interval a, b is equal to the area, the integral from a to b of f divided by the width of that interval. And we talked extensively about why that makes a lot of sense. So let's just do it kind of in the context of this problem. All right, so that's the first step. The first step is let's just find the average value of f on the interval 1, 3. How do we do that? Well, the width of the interval is 2, and then we just need to take the integral basically, right? We take the integral from 1 to 3 of 9 over x cubed, and 9 over x cubed, and then after doing that, we're going to divide by 2. Okay, how should we do this? Well, it's not that hard, I guess. This is 1/2, and it may be best to write this as 9 over x cubed, or even we can just factor out the 9, and we get x to the -3, evaluated, or going from 1 to 3. Okay, and now there are maybe some advanced ways you could do this, but with the fundamental theorem of calculus, all these kinds of problems like this are now easy, because I can compute this integral if I know an antiderivative of x to the negative 3. And I just do know an antiderivative of x to the negative 3. I go up a power to negative 2 and divide by negative 2. And so what we get is 9/2 times negative half x to the negative 2. And you can confirm to yourself that we anti-differentiated correctly, because if you differentiate negative 1/2 x to the negative 2, you get boom boom x to the negative 3. Okay, and so let's see, this becomes, if we factor this all out, negative 9/4 times 1 over x squared, 1 over x squared, evaluated at 3 and 1. And if you just do this, let's see, we get negative 9/4 times, when x is 3, this is 1/9, and when x is 1, this is 1. Okay, so we're calculating the average value. We take the integral divided by the width of the interval, which is 2, factoring things out, applying the FTC, and this is then negative 8/9. So negative 9/4 times negative 8/9 is in fact just 2. Okay, what have we just determined? We've just determined that on average, this function is 2. Is that a reasonable answer? I think it is. And okay, this picture is probably just sort of not to scale, but what if the average value of this function is 2, then what that is really saying is, well, it's sort of saying, again, just to repeat myself, that this function on average has value 2. And that's looking somewhat reasonable here according to this picture, because this, I tried to draw a height of 2, and what it means for the average value of this function to be 2, one way of interpreting this geometrically is that this area, all this blue stuff outside the rectangle, perfectly fits inside this spot, such that sort of, okay. And that makes sense when you realize that what we have really done here is, well, okay. What we have really done, what you really do when you find the average value is you find this height 2, such that the integral, which is, I guess, just 1, is that true? Yeah. That entire integral is just, 4. The entire integral is just 4. So this green stuff, if this green stuff was 4, then what we really did when we found that the average value was 2 is we said 2 is the height of the rectangle such that the area of this rectangle, 4, is equal to the area under this curve, which is 4. Okay, anyway, that is the average value, and now there is this thing called the mean value theorem for integrals, and the mean value theorem for integrals says that there exists a point at which this function obtains its average value. In other words, there must be some number, usually people call it c, this is what we want, at which, on that interval, the value of the function at c is equal to the average value of the function on that interval. And the deep way of thinking about this is if this is a velocity versus time curve, then the total area under the curve, the green, would be the distance traveled. So this object has traveled a distance of 4. And the average value of this function is 2, which is to say that the average speed on this interval is 2. Which is to say, 2 is the speed we could have been going at the velocity we could have been going at that entire interval to achieve the same distance traveled as we did according to our variable rate velocity. Anyway, and what this finally says is that somewhere on that interval, the object was going at an instantaneous velocity equal to the average velocity. Alright, so the final thing we need to do is to figure out when is the function 9 over x cubed equal to 2. And, alright, so that's it, right? You get that x cubed is 9/2. And so the answer is x equals cube root 9/2. And 9/2 about 4.7. This is like looking pretty good. This is 1 something. I don't have anything else to say about that. Okay, good. More. there are two more problems which I think are kind of basically the same thing, so I'll go a little bit faster. Okay. Okay. 57 says, find the average value of the function over the given interval and all x values in the interval for which the function equals its average value. So it's almost the exact same problem. We're given this function, f of x equals 4 minus x squared. 4 minus x squared on the interval -2, 2, and we are asked to find the, first of all, to find the average value of this function. Okay, let's make a picture, because I do think this aids in understanding. So it's 1, 2, boom, boom. So, okay, what does this function look like? It looks, well, it looks just like an upside down parabola. Sure, and now there's a certain amount of area inside here, and what we want to know is, what is the average value of this function? And I'm guessing it's going to be maybe here? Something like that is how big this function is on average. Remember, it's, okay, well, let's just compute it. To find the average value of this function on this interval, we should take the integral from -2 to 2 of 4 minus x squared, and in other words, all the green area, and then divide by the width of the interval, which is 1/4. Okay, and here it's just too tempting to observe that this function is even, and so really what we're going to do is just take the integral from 0 to 2 of 4 minus x squared and multiply by 2. Okay. What we really have is 1/2, and I think we can just do this now. What is the integral from 0 to 2 of 4 minus x squared? I'll just use the fundamental theorem of calculus. It says that this is 4x minus x cubed over 3, anti-differentiating, evaluated at 2 and 0. And so we get 1/2 times, it's important to be very, well, in this case it doesn't matter, but 8 minus 8/3, and then the rest of these are just all 0. So what this becomes is, let's see, 24 minus 8, 16/3, but half of that, so it's 8/3. So 8/3 is almost exactly what I have drawn here. It's a very reasonable answer to what's the average value of this function. It's on average, this function is 8/3 tall. Okay, the second part of this problem just said, the mean value theorem for integrals says there must be some point at which this function obtains its average value, and this problem just says find all x values on the interval for which the function equals its average value. So we just want to know when is 4 minus x squared equal to 8/3, and well, okay, so whatever this is, right? 12/3 minus 8/3 is 4/3, so I guess this happens at plus or minus 2 over root 3. And 2 over root 3 is going to be a little bit more than 1, because it's like 2 over 1.7, so everything's looking really pretty good here. Nothing more to say. Okay, second to last problem now, and the problem 109 made a special video for that last year, so that'll be coming up next. Anyway, that is 59. Same directions, 2e to the x is now the function. And we're looking at it on the interval from -1 to 1. This function is not even, so I can't do that kind of, trick or whatever anymore. Not a good picture. Okay. So when I plug in -1, I get 2e to the -1, that's 2 over e, so it's like 2/3 or something, and, this is a bad scale. When I plug it, let's plug in 1, when I plug in 1, I get 2e E is 2.7, so this will be about 5.4. So let's do 3, 5, and that's 1. So we're going to be up here. And when I plug in 1, I'm going to get 2. And when I plug in -1, I'm going to get 2/3. I guess it doesn't really matter to have such an accurate graph, but I think it does help. So there is my curve. And I want to know how big is this curve on average. And to know on this interval, and well, once again, I just apply my understanding of average value. So we take the integral from -1 to 1 of 2e to the x, and then we divide by the width of the interval, which is 2. Okay, so really this becomes basically immediately just the integral from -1 to 1 of e to the x, and this is very easy to do because one of the antiderivatives of e to the x is just e to the x. So this whole thing becomes this, and so what we get is e minus 1 over e. So e minus 1 over e is the average value, which is going to be like, I don't know, 2.7 minus 1/3, so 2.4, something like that. And if you look at this, you know, you can convince yourself that 2.4 is maybe a reasonable answer to this problem. Okay, it will look better if your graph was done not by hand. Okay, and the final thing we need to do is to ask when, if ever, is our function going to equal this. So I don't know how to do this, but I guess there's no real way to, well, okay, so when is 2e to the x ever going to equal e minus 1 over e? Should I get a common denominator? I don't even know. E squared minus 1 over e. And then therefore e to the x is e squared minus 1 over 2e. And so you just take the natural log of both sides. So x is ln of e squared minus 1 over 2e. Bet I could like do some things with that to make it prettier, but I'm not sure if it's worth it. I bet that's right. I'm just paranoid, so I will check this. 3 over ln 4. Oh no, 59. Yeah, ln of e minus 1 over 2. Yeah. Yeah. That's all there is to say. Ln of that over 2. Yeah, so you could do some fancy things maybe, but that's not important. Okay, so there we go. That was the homework on the fundamental theorem of calculus, and then there's a separate video for number 109. Goodbye!